Let's take a moment now to talk about how we would reduce fractions. And let me use an example to talk about that. So let's say I start with the fraction 35 over 20, and I want to find a way of reducing, that is making smaller, both the numerator and the denominator to form an equivalent fraction with smaller values in the numerator and denominator. You can see in the box that the way we need to do it is by dividing the numerator and the denominator by the same non-zero whole number. So in this case, 35 over 20, I can easily see that if I divide this by 5 and divide the denominator by 5, I will get an equivalent fraction of 7 over 4. At this point, I cannot reduce 7/4 any further. In other words, 7 and 4 do not have any common factors that can be divided out. So we now know that 35/20 is equivalent to, that is, it equals 7/4. Okay, so there's how we would reduce that fraction. Now, suppose we take a look at a second example, and I'm going to show two different ways that we could reduce this particular fraction, 27 over 126. I begin by noticing that 27 can certainly be divided by 3, and then also 126, if I add the digits, 1 plus 2 plus 6 is 9, and that's divisible by 3, so therefore 126 is also divisible by 3, and I'm going to go ahead and do that. I can get that this is equal to 9 over 42. Now at this point, it turns out that fraction, 9/42, is equal to 27 126, but even more importantly, I can still continue to reduce this fraction. In fact, this is also divisible by 3, as is 42. And when I do that, I get 3 over 14. Excuse me, I just made a mistake there. Let me change that to a 3 in the numerator. So again, that is 3 over 14. And at this point, I have reduced this fraction to lowest terms. That is, the numerator and denominator no longer have any more common factors. Now that's one way to go ahead and reduce this fraction, is to just keep dividing by numbers that I think might divide into the numerator and the denominator. There is another way that we could have done this. Let me go ahead and show that second way. Let's take 27 and 126. And what I'm going to do in this case is I'm going to go ahead and let's move this out of the way and start from the beginning here. So 27 can be factored into its prime factors, and when I do so, I see 3 goes in here, 3 goes into 9 3 times, and then lastly 3 goes into itself once. And then I can do the same thing with 126. I can see that 2 goes into 126. It's an even number. It goes in 63 times. 2 doesn't go into that, so now I'm going to try 3. 3 goes into 63 21 times. 3 goes into 21 7 times, and then of course 7 is prime, so that's my last factor for 126. So I can now rewrite 27 over 126 as 3 times 3 times 3 over 2 times 3 times 3 times 7. And what I'm going to do now is, in the numerator and the denominator, I can go ahead and divide out all the common factors in the numerator and denominator. So notice there's a 3 up here and there's a 3 down there that they can both cancel out. What I'm really doing is I'm dividing them both by 3, and then this and this cancel out, and they leave behind a value of 1, because again all I've really done is divided the numerator and the denominator by those common factors. Now I can go ahead and multiply across. 1 times 1 times 3 in the numerator is 3. 2 times 1 times 1 is 7, is 14. And so again, I wind up with 3/14 as my answer by using this method of canceling common factors in the numerator and the denominator.